So there is quite a large background, mainly of animal research, that suggests that as animals such as mice or rodents get older, they show abnormalities in their stress hormone system. So for example, if you stress an old rat compared to a young rat, not only will it show a bigger response in terms of the hormone it produces, but interestingly, it takes much longer for that to come back to normal. So in other words, it's exposed to much higher levels for a longer time period. If we move on to humans, there is a disease called Cushing's disease, which is actually due to a tumour in the brain, where the body just produces too much stress hormone called cortisol, and it doesn't have the normal regulation to bring it back down as it should do. Now, if you look at these patients, they have a large number of adverse events in relation to their tumour. So, for example, they'll have more likely to have high blood pressure, they're more likely to get obese, particularly around their tummy, what we call central adiposity. They're more likely to have thin bones, like osteoporosis, and they're more likely to get muscle wasting or weakness. Now, these are all things that we would all recognise get more common in older people. Hence, it's quite plausible that ageing may be associated with abnormalities of the stress hormone system. Now, if you now look at normal populations without this problem, what you'll find is twofold. Firstly, all of us have marked variability of our stress hormone during the day. So when we wake up in the morning, we have very high levels, and before we go to bed at night, these levels will be much lower. What's interesting is if you measure someone on several days, you'll find that that even varies. So for example, if they had a bad day or if they had to be interviewed for a program, they'd have much higher stress hormones than if they had a relaxed day. And if you compare groups of people, you'll also find variability. So all of these factors suggest that maybe this is one potential explanation. And actually, finally, if you ask the man or woman on the Clapham omnibus, what does stress do to you? They'll all say stress is pretty bad for you. If nothing else, it makes your hair go grey, which is a classic sign of premature aging. So the purpose of this package is to build on existing knowledge. There have been previous studies looking at how stress hormones could affect aging. In general, though, these studies have been very small, non-representative, and they've only looked at things at the same time. So they measured the stress hormone and then the aging trait, or the aging phenomenon. What we're doing in this package is bringing together 5 fairly large studies, so we'll have data on over 8,000 participants. In that way, we can test our hypotheses in a very robust, powerful way and see whether we can really see whether there are associations or not. So there are several research questions that we hope to answer. The main research question is, to what degree do patterns in stress hormone production predict aging traits, such as the ability to do certain physical performance tasks, such as walking or balance, mental performance tasks, such as memory or reasoning, and psychological well-being. In addition, we're going to look at stress hormones in midlife and later life, and we want to see whether even in earlier life can we predict aging, or does the combination of both time points have a better predictive model than the later time point. Thirdly, in parallel to the other work packages, we want to see whether our results explain some of the variability in aging, for example, comparing men to women, or people with poor socioeconomic status to more affluent socioeconomic status, or, for example, obese individuals to thin individuals. Fourthly, in relation to the package on telomere length, which is the body's biological clock, we would predict that if cortisol hormone is important for aging, people with abnormal patterns would show shorter telomeres, hence more rapid biological aging.
So we've measured stress hormone cortisol in several studies, and there's complete measures in some studies, but not in other studies. So we're focusing on the carefully prospective studies so far because there's complete measures. And these are men when they're middle-aged and the same men when they're elderly. And the results that we've found in middle-aged men, we've found that high morning cortisol is associated with faster walking speed, and that is surprising. In the elderly men, high nighttime cortisol is associated with slower walking speed, and high nighttime cortisol is also associated with poorer balance, which is what we expected. And a smaller diurnal drop is also associated with slower walking speed. So to explain these findings, in middle-aged men, at first it's surprising because high morning cortisol is supposed to be bad, so you'd expect poorer physical capability. But these men were stressed, they were fasted at an overnight fast, therefore they actually produce a high stress response, which is a good response. So that can explain those results, and so overall a more dynamic stress response where that's a larger diurnal drop and lower nighttime cortisol is associated with better physical capability. So if we put together all these results, if you have a more dynamic cortisol profile, you will be aging less rapidly. So what will be done in the next year, so we'll extend the analysis to other cohorts for both physical and cognitive capability, and we'll get a complete data set for the other cohorts as well, so NSHD. We'll also see whether our studies can explain or partially explain the information from some of the other work packages. So obesity is associated with poor physical capability. So do we find abnormal cortisol profiles are associated with obesity?
Potentially, there are several important impacts of our research. Firstly, if we do find important relationships between stress hormone and aging, we hope this will act as a further stimulus for basic scientists to explore the mechanisms and potentially come up with targets that could be intervened at a pharmacological level. Secondly, we hope to use our information to look at predicting frailty with other measures. We obviously don't think that cortisol is the only factor that's important. And in theory, if we put together our findings with the other packages, we could develop something like a frailty index. Now, why would that be useful? Well, several reasons. For example, doctors, clinicians could use it to identify those people who are most vulnerable to further adverse events. So, for example, if you came into hospital for major surgery and you could predict who might do badly and recover less well, you might be able to do something beforehand. Or similarly, you might be able to target interventions to those people who have most to benefit. In particular, one of the things that we would need to do for future research is to see to what degree do interventions such as exercise improve the stress hormone balance or the profile, in which case we could use that as a sort of measure of whether people are really gaining benefit from the intervention. And then finally, we would hope that our results would be taken on board by public health scientists and policymakers. So, for example, a previous study, the HALCyon study, found that people who feared financial difficulties in the future, for example, when they retired, had an adverse profile. They showed less normal variability. And given the current economic climate and discussions around pensions, this is a major factor that older people should be considering. And similarly, policymakers should take this on board when deciding what is the best policy.